Hey everyone, it is time for another recitation. This time we're going to be going over the WebDB 4 stuff, which is going to be designing table schemas that have various kinds of relationships, one to many, many to many. The trappings of our project today is creating a database to hold movies and informations about the movie. So our core driver here, right, is we're going to have a movie, and that's going to have some information associated with like a title and a release year and things like that. But movies also have actors, and actors can be in multiple movies. So there's a very clear many to many relationship. And we also have some data that goes in that intermediary layer of the character that the actor plays inside the movie. And there's lots of ways we can take this. Movies can have reviews, and we can use that to build a one-to-many relationship. And we can even design our schema to be much more general so that we wouldn't have to make separate tables for directors and gaffers and lighting people. And I'm going to start out by writing our schema in a straightforward way to handle the actors. And then if there's time, we'll refactor it into a more general pattern to be able to support any type of person who worked on the movie. So our project here is empty. We are starting from bare bones here. So I'm going to open up a terminal, and I'm going to do yarn or npm init, and I'm going to say yes to all the things. And then I'm going to add my dependencies, which are going to be express, next, and SQLite 3. And then I'm going to add NodeMon as a dev dependency, and we're going to start creating our boilerplate files, like our next config, and then our database connection, and all of that. So I forgot to pause Slack notifications, which I always forget to do. All right, great. And then we're going to add NodeMon as a dev dependency. So yarn add dev NodeMon. And here we go. We're starting to get some stuff in here. And then I am going to do npx next init to create our next file. So by default, we have our next file that has a bunch of stuff in it. I'm not going to use the staging or production objects. I could leave them in there. They don't do any harm, but I'm going to get rid of them for now. I want to add the configuration for where my database is going to go. I'm going to put that inside of the data folder, and I am going to call this movies.db3. You can change that extension if you want to. And then we're going to set up our migrations so that they also go in the data folder. So that's going to be directory, and then /data/migrations. And then we're going to do the same thing for our seeds. Awesome. Now the last thing we need to do is when we have foreign key relations, by default in SQLite, those are not enforced. This is not something that we're going to find to be the case in most other database management systems, but while we're working in our development database connection with SQLite, we're going to need to add essentially a command that is going to tell SQLite, yes, we do want you to enforce foreign key relationships. And so we do it under this key called pool, where we're allowed to specify another key called afterCreate, which is a function that is going to run after the database connection has been established. And it gives us two arguments, a connection object, and then a function called done, which we run as soon as we're done performing whatever operations we want to. On the connection, we can run a SQL command, which is going to be pragma foreign keys equals on. And then we'll give this the done command, and when this command is finished executing, it will do its business. So that's just boilerplate. Honestly, just reference old projects and copy and paste this in. I just want to show this process from start to finish. So we should have some stuff in there. I'm going to create the data folder, and then I'm going to go inside of the data folder, and I'm going to create our db.js to hold our database connection. So I'm going to require next. I got to save that into a variable. I'm going to require our next config, and that's coming out of our next file, which is just up a layer. And then I am going to export our database connection, which is just running next on the next config. I'm going to hard code in our development connection. There we go. So now I should be able to run npx next migrate make bootstrap. And we should be good to go as far as starting to write our schema. But we shouldn't start here. Never start here. Unless you're like so clear on what you're going to do. We should always try to plan out our schema before we try writing it in a migration. There are lots of wonderful database designer tools out there that you can use, but at least for me, the first step that I always take is a pencil and paper. Whenever I start writing any program of sufficient complexity, pull out a pencil and paper, just kind of sketch out what you think it's going to be like. And in order to share that with you, I have pulled up a painting program here. And we are going to kind of sketch out the design of our database. So, fundamentally, we're going to have a table called movies. And you all get to see my very wonderful handwriting. And we're going to have various information about the movies. And we don't have to be super exhaustive in this example, but we should probably have a title. And I'm also going to go with a year it was released. A lot of other information we can include, but this is enough, for our sketch, at least right now. And then we're also going to need to have some actors. And actors are going to have information about them. Most importantly, they're going to have a name. But the thing is, movies have actors in them. And actors are in movies. But movies have more than one actor, potentially, unless you're watching All Is Lost starring Robert Redford. I think that's the name of that film. I don't know. I should have prepped beforehand. And actors can also star in multiple films, hopefully, if they do a good job. So here's our many-to-many relationship. So I can't just draw an arrow between these two because, right, we can only have this kind of one row to one row relationship between two tables. But I can drop an intermediary table in here, which we could call something like movies underscore actors, right? It's just kind of a default naming convention for an intermediary table. If we have the opportunity to, it can be helpful to call this something slightly more significant, like we could call this cast or something like that. Which, you know what? Yeah, that's what I'm going to call it. Because sometimes our many-to-many relationships aren't very well expressed in terms of table names mapping onto the physical connection between our data, but this one is actually pretty good. And this movie project is used as a somewhat canonical example when trying to illustrate these types of relationships. So how this is going to work is that our cast is going to contain an actor ID, right? We want to reference the actor that is in this role. And then we also need a movie ID, right? We want to keep track of the movie that this actor is in. And then we want some other information. When an actor is in a film, they usually play a character. So in this relationship between the actor and the movie, I'm going to include a piece of data, which is the character that they play. And this is our basic setup for this many-to-many relationship. We can add in a one-to-many if we want, and I'll see how I'm feeling about time. We could have reviews. Each movie can have many reviews, but a review is meant for only one movie. And so this could have, a rating and other information in here. And it would just need a movie ID because it's a one-to-one, right? Each review can keep track of the movie that it is referencing. So this is going to be the basic schema that I'm going to start with. Do we have any questions about this so far? All right, cool. Let's get cracking then. I'm going to move this over so we can reference it while we write our schema. So that's going to go there. And then I'm going to plop this over here. And can I not compress that any further? I guess I cannot. So, all right, maybe I can do this. Nope, whatever. That's fine. So we want to start writing our schema, and we can do this in multiple migrations, one for each table. For the sake of simplicity here, I'm going to do this all in one file so we can see it all as we're writing it. So we got to return our promise, and we're going to do next.schema.createTable. And the first table I'm going to create is movies, and we're going to receive the table as the argument to our callback, and we're going to start writing out the schema. I am going to do table.increments as always. Did I spell that word correctly? I did not. And we can choose to name this like movie ID if we wanted to. I'm going to leave it as ID. We're going to have other information like the year, which I'm just going to represent as a string rather than a date because that's going to make it easier for me to see the data. Oh, we need a title. So table.string title. This year should be not nullable, right? A movie has to come out, and a movie also needs a title. At least I don't run in super, art cinema circles, so maybe they don't. We could obviously add in more information here, like a description and things like that, but I'm going to keep it simple for now. We're going to chain another call to create table on here, and let's create the actors table. And all we're going to have here is an ID for the actor, and then we're also going to give them a name. And for those of you following along at home, please feel free to add character and color to your heart's content. But I'm trying to go fast. This should also be create table. And I'm going to keep these on the same indentation level because that will make me happy. And then we're going to create a table for our intermediary table, right? Which we could call movies actors or actors movies. We just need some name to represent the relationship between the movies and the actors. Sometimes our data allows us to use a physically meaningful name, like cast. And I'm going to do that here because I can. Let me ask you, would you rather I use a generic many-to-many name or the descriptive many-to-many name? Any opinions? All right, I'm going to stick with cast then. And so, definitely descriptive. All right. I'm just not sure because sometimes most of the time, you won't have a nice descriptive name like this. So I don't want it to be unrelatable, but we're going to use cast. And so what we're going to have here is we're going to have our table needs a primary key. And we don't necessarily need to reference this primary key very frequently. We will need some way to reference this row in the case that we want to, delete an actor from being in a film. But we don't have to do that by a primary key, right? We can use wheres, and we can find the actor ID and the movie ID. We could also make a composite primary key here. But I'm just going to give it an ID to keep it simple. And if we have time, I'll show how to use a composite primary key here, and then also how to reference that as a foreign key. So then it's going to have two other pieces of information. It's going to need to reference the primary keys for the movies and the actors, and then it needs one actual bit of fun information, which is the character name. So I'm going to do a table.integer, and I'm going to call this movie ID. And this is going to be unsigned. Our primary keys we make with increments, by default they're unsigned because they start at 0 and go as big as they can. We don't want them to represent negative numbers. And then it's going to be required. And it is going to reference the ID in table movies. And we're going to repeat this for the actor ID. So we're just going to replace movie with actor. And there we go. We have our two foreign keys. Now we're going to add a string that contains our character name. And there's probably a better word for this than character, but that's what I'm going to use. And so that's it. that is
I have a
it.
quick question.
Yeah, absolutely.
I remember, I think yesterday or the day before, you were saying like, um, even though a column might have integers in it, you wouldn't necessarily want it to be like type integer.
Hmm.
Is that not the case for like primary keys usually?
You can have primary keys as strings. There's a slight performance loss to using non-integers as primary keys, just because doing comparisons against integers is quicker than doing comparisons against strings. Um, but like with the car project or with the books example, you could use the VIN or the ISBN as the primary key, and that might also be good because you're using less storage per row, which when you have millions of rows can also matter. And the performance hit really isn't going to be that essential. You could also have an integer primary key, and then if you're going to look up frequently with the ISBN or the VIN or something like that, you can make that an index, which will make lookup fast, like lookup on a primary key is. Um, but by default, the primary keys we're going to use are going to be integers because comparisons are fast. We don't need to do math on them, but also we're never going to try. And and kind of the reason that we don't want to represent non-math as integers is like when I gave the example the other day of the student ID, which was a very, very large number that's actually a string. And that can overflow, what numbers on our computer can actually be stored as. With the primary key, we're making them unsigned auto increment numbers. So we know that they're going to go from 0 up until the largest number our computer represents, which is going to be pretty big. For 64-bit computers, it would be 2 to the 64th power, which is large. Technically 2 to the 64 minus 1. Um, Very big. But also, some people prefer random primary keys, and one of the great ways to do that is I've mentioned in the past UUIDs, universally unique identifiers. I think is what that stands for, and it's basically a random string that is. It's so unlikely for you to get a collision, the same value for it twice, that it's essentially negligible. So those are also a choice for primary keys. Or like when you make a YouTube video, right? It gives you the random hash at the end. You can use things like that for primary keys. They just have to be unique. Numbers slightly faster, but you can use strings or anything else that you want as well. Does that answer your question?
Yeah, thanks.
Okay, great. Yeah, so this is it for our many to many. We have one table that has the information that's directly relevant to it. We have another table with its own set of information. And then we have an intermediary table that contains primary keys from each, and then any information that we associate with that relationship, which we will not always have. Sometimes we just want to relate these things to each other. Like in the books example, uh, we could actually do it here with genres, right? Many movies movies can have more than one genre. Genres can have more than one movie. There's nothing important information that we want to quantify other than that they are related to one another. So we don't always have a row like the character or a quantity or something like that. I'm also going to make this not nullable while I'm at it. Okay, I think that's good. This should also be not nullable. And that just about covers our basic many-to-many schema. Do we have any questions about it so far?
Hey Henry, what is
Yeah.
I think in the example that we had either yesterday or today in the migrations file,
Mm-hmm.
there's a primary method on the table at the very bottom, and it
Yeah.
takes an array of the different columns.
Yes.
Can you explain that?
So if we look at the schema for our database, I'm going to run this migration and check and see if I have any bugs. So we're going to do npx next migrate latest. Oh, we got a bug. It's a big bug. Um, is it references? It is, isn't it? There we go. So I'm going to pull up the terminal client, and I'm going to look at this inside of SQLite. So cd into the directory, and I'm going to open up SQLite 3 on our database. So I can see the tables in here, and I am going to look at the schema for movies. And we see that this is actually a poor example, but we see that ID is the primary key, right? And we can look at another table, and we can see that, what do we want? Let's do the cast. Indent cast. We can see that this also has a primary key, but notice how the foreign keys, right? This is a separate constraint here. If I were to make things unique, which maybe I should have, but movies can have, different things. I don't think we actually needed uniques anywhere. We notice that we have these values in here, movie ID and actor ID, as integers that aren't null. And then separate than that, we're adding this additional constraint that they are foreign keys that reference certain columns in other places. We can do the same thing with primary keys. We can add a constraint here specifying that one row or perhaps many rows are primary keys. And that's actually how we would do it when we're writing raw SQL. It's just that next gives us this nice increments thing, which is going to make things primary keys. And we can also chain a call to .primary to make something primary. But I would be allowed to here make this an integer called ID, and then make it unsigned. Yep. And then make it not nullable. And then I can specify separately that our table has a primary key and that it is going to be ID. I would also need to make this auto increment, which I'm not sure what the method for that is. If I would do that on here with next, just because I'm going to have to refer to next documentation frequently. Let me write my down migration, and then I can show you how this works. So here, we just return next.schema.drop table if exists, and we're going to want to drop the cast first, and then we're going to drop actors and movies. So now I can do npx next migrate down or migrate rollback to undo this, and now I can migrate back up to latest. So I can go back into my terminal. I'm going to open the database up again. I don't think that should matter. So here are my tables, and let's look at the schema for the movies table. And we can see now we have this constraint at the bottom that our primary key is ID, and it's separate from the definition that we had here, but it's going to work essentially the same. And we could specify multiple values of our primary key. We can also specify multiple values when we're creating a unique thing. Our constraints can involve multiple columns. So for example, this is actually something that I wanted to do and I forgot. An actor can be in many movies, right? So this actor ID isn't unique. And a movie can have many actors, so this movie ID shouldn't be unique. But an actor can only be in a movie once. I'm not sure what the SAG-AFTRA rules are about that, but I think an actor can only be credited in a movie one time, but maybe I'm wrong. So what we can do is, in the same way, instead of writing unique on those individual columns, I can call table.unique, and I can say I want you to make the combination of the movie ID and the actor ID unique. So we can't have actor 5 in movie 2 twice, but actor 5 can show up as many times as they want. Same with movie 2. So let's migrate down again. And then let's migrate back up. And now let's see if this schema auto updates. And let's look in cast. Yeah, we see we now have this unique index, again, separate from the declarations of these individual columns, saying that both of these together are unique. So that's what the table.primary, the table.foreign, the table.unique lets us do. And it allows us to specify the constraints on our table separate from the declarations on the individual columns. Does that answer your question?
I think so, yeah.
Okay. And in the same way, we can have this composite unique index, right? These two things together. The primary use case for using this dot primary instead of chaining dot primary onto here would be making multiple columns the primary key, which I honestly don't know what would be the use case that would really compel you to do that. We could do that on this table cast to avoid having just this arbitrary ID that really doesn't mean very much here. But I don't feel like doing that very much right now, so I'm not going to.
Yeah, I had a question, Henry. So for the composite key, we could do that, like for example, on a many-to-many relationship, like where you have a third table. You could just do a composite key on like both of the foreign keys. Would that be a good use case?
Yes, it would be one of the valid use cases. In the same way that we want both of these to be unique, we can also just make them the primary keys together, because one, primary keys have to be unique, so that takes care of that constraint. But two, most of the time when we do lookups here, we're not going to be doing it against the increments ID. We're going to be doing it against the movie ID and the actor ID. And when we make things the primary key, they are indexed in such a way that lookups against them is going to be quick. So this would be a place where we could do that. I don't want to do it right now just for the sake of avoiding some complexity, but if we have time, we can absolutely see how that would work. So I'm just going to reset this back to the way it was. But yeah, we can have composite primary keys. I want my my composite uniqueness though, because that is important to the design of this database, that those together are unique. And that is our schema. Do we have any other questions with this? I see Eli typing. What does the primary key look like when you do? Yeah, so the primary key is just both of them. So if we wanted to reference it as a foreign key, we would do very much like what we have here. We would create two integers unsigned not nullable. We would create the same data type as what we expect the primary key to be. And then instead of doing this dot references in table, we would do table dot foreign, which is a word that I struggle very much in spelling. And we would say that, hey, these two columns in our database are going to reference foreign keys in tables, and so on and so forth. And we can look up the syntax for that just to be sure. Foreign. Yeah, so we would do table foreign. We would just write this foreign constraint for both of them. So we would say foreign for both of these columns references, you know, the same set of columns, although we can name these differently. In table cast. So that's how we would reference the foreign, or the primary key as a foreign key. We just create all of the columns that are going to be inside that primary key, and then we would add the foreign constraint separately, saying that our group of columns are each going to represent the foreign keys inside of, or the primary key inside of another table. So that's how we would do that.
Is that just like a shortcut way of doing it, like independently?
This is the way we would have to do it because it's not that each of them, or actually you might be able to do this in this manner where you could have them reference each of the things inside of the table. I don't know if that would work based on the way that Next interprets that query as it builds it. But this is how this would be a valid way of representing it, at least. I don't know if it's the only valid way or not. Where we would say, all right, this grouping of these two columns represents and I think this is why you'd have to do it. It's not that each of them represent the primary key, right? It's both of them together represent the primary key, which is made up of two columns in the other table. So I think this is how you'd have to do that, but we can test that out later.
So how would you reference, if you wanted to, for some reason, reference the primary key of this table, like how would you do that? What would it be the value?
This, exactly what I have highlighted here, right? We would make in some other table two columns, movie ID and actor ID, which would both be unsigned integers they don't have to be non-nullable, but they can be. And then we would reference the movie IDs and the actor IDs in the table cast. So I've done this entirely within the cast table, but we would make some other table named like, something else, and it would have, the movie ID and the actor ID inside of it as well. And that is how we would reference the primary key. Does that make sense?
Yeah, I mean, it kind of does. I would have to play around with it, but yeah.
Yeah, and I would recommend doing so. Just leave that commented out here. And I think everything is correctly working. Composite uniques, super useful. There's also ways of running functions on these, so you could have like the lowercase version of one of the values and combined with another thing needs to be unique, which is pretty cool. Okay, so any other questions on our schema here? I see Jocelyn typing. Okay, a question about the schema for today's project. I'm confused about making a table for ingredients because it gets a little complicated. So I don't want to go too deep on the solution for today's project, but what the README suggests is that ingredients aren't actually like milk. Ingredients are a cup of milk. And then you define the quantity in the intermediary table between the recipe and the ingredients, like we've declared the character name and being in the intermediary table here. If you wanted to, you could have another many-to-many relationship in between a table called units and a table with your ingredients in there. There's a lot of ways to take today's project and make it significantly more complicated, but also more robust. I would recommend getting it working with the basic schema. That will work and represent the data, perhaps not ideally, and then iterate a little bit, because what would be somewhat counterproductive is when you're writing your first set of tables like this to strive to make it absolutely perfect the first time. Because one, you're going to deprive yourselves of the lessons along the ways of writing slightly incorrect schemas and then improving them. But two, you're going to spend so much time designing the schema that you're not going to get to writing your joins and your endpoints and writing that full stack of integration there. So get something that works, get something that's simple, like having the unit be inside of the name of the ingredient, and then try to see if you can split those out and write a relationship for that. All right, cool. Any other questions about this schema? Okay, so our schema, movies table, actors table, intermediary tables that contains references to each of those keys, and then any information that we want to come along with it. We can also do cool things like set uniqueness on the composite of 2 columns, which is very cool. So now I'm going to write my seeds. So I'm going to do what I can to make this bearable. And in our terminal, we're going to run npx next seed make. And I'm not going to create individual seeds again, so we can just kind of see everything in one file without bouncing around. I honestly would recommend separating those out, but you're going to have to start with a file that's going to clean the whole database up. Otherwise, it's going to give you a lot of headaches trying to deal with foreign keys, because fundamentally, you can't insert a column that references a foreign key until you have inserted the thing that you were referencing, right? But when we run each one of our seeds, by default, we truncate that table. And so we end up in this perfect gridlock of we're trying to delete the things foreign keys reference before to add the things, so then we can reference them in a later seed file. So don't forget that. I'm just going to do it all in one here. I'm just going to call this file seeds. So now I'm going to go into my seeds directory, and we're going to write this thing. So what I'm going to do is I am going to just do all of my truncates right at the start. So I'm going to truncate first the casts table, right? Because that has foreign keys that reference stuff. I have to delete those before I delete the parent that is being referenced. And I need to spell truncate correctly. Then, when that's done...
It's still not spelled correctly.
Oh, man. Whew. I'm not very good at spelling. I'm also going to turn on line numbers. All right. So then, once that truncation is done, right, we have to chain a dot then on here. I'm going to say for the actors table, I'm going to truncate that. Then, once that is done, I am going to truncate the movies table. And this is essentially what your seed clearing file would be. All right, and once all of those are done, I am free to write my seeds. And I'm going to make this an arrow function because I like it. I'm going to remove this comment because I know what it does. So then, for the movies table, we'll start out with this one. We're going to insert some rows. And when we're working with SQLite, we can manually insert the auto incrementing keys, and it won't cause any problems. With Postgres, you will get errors because that will not cause the key to auto increment. I'm going to keep them here just for clarity, so it's easy for us to see, which movies have which actors, rather than having to count their position to figure out what key they'll end up with.
So, yeah, to clarify on this, so you're saying SQLite 3 automatically assigns IDs even if you don't seed them?
Yeah, so you can provide the ID column when you make the row. You can do that on, I'm hesitant to say all when talking about database management systems because I don't know. But at least for most, it will accept that ID. And Postgres will do it happily, but it messes up the auto incrementation in Postgres. It won't auto increment the counter, so then when you try to insert the next thing without supplying an ID, it'll throw you an error because there'll be 2 primary keys with the same value. SQLite will see that, put that ID right in there, and it will perform the auto incrementation. So it's fine if I include these IDs in my seeds, but not when I do Postgres.
So for Postgres, we have to actually take it out to avoid errors.
Yes.
Okay.
At least that is my experience with it. There may be a way to get it to do that. There's probably a pragma thing we can set or something like that. In my own experience in Build Week, that is what I had to do to make that work. What did I want to say? This is a JavaScript file. So if we have functions written in our models that will, take a nicely formatted movie and insert all this stuff correctly, we can use that. We don't have to do the manual approach that we're going to go to here. But I would encourage you, just like your test, to try to keep your seeding files simple, because debugging your seed files in the same way that debugging your tests is very frustrating, because you're debugging the thing that's supposed to help you, help you solve other problems, and you spend a lot of time on it. So if you can keep this simple, So I'm going to insert some movies. I'm going to leave the ID in here, and our movie has a title, and I haven't thought of what movies I am going to use. So let's do, what's a movie?
There's
Oh,
a new
shoot.
movie by Apple. Apple TV. It's called C.
See?
It's a C SEE.
Oh.
Yeah, like all the humans are like they can't see anymore. Like
Oh.
God took away their eyesight. It's like hundreds of years in the future.
Okay. Well, we got C in there. Let's do It's a Wonderful Life, which means I'm going to have to use different delimiters here. I don't know if It's has a... This is how we spend our things productively. Yes, it does have an apostrophe. So It's a Wonderful Life. It's a good film. I need to figure out when it came out, though. Probably like 1810. Oh, it's 1946. That's my dad's favorite movie. I think now you can all hack his bank account, though, because that's probably a security question. What else do we want in here? We want... Let's do Jaws. Jaws came out in 8. Came out in the year 8. Yes, we would be able to escape this this apostrophe to get it to work inside of single quote delimiters, but I don't have to do that. I can just use other delimiters. We can also use backticks. Cool thing about backticks, you can also have new lines inside of backticks. If you need to insert, like if we had a description that had, you know, multiple paragraphs of text, we could use backticks in order to get the new lines in there, which is pretty cool. Jaws. Thank you. 1975. All right. And I think that's probably fine on movies because I don't want to write out all the actors for each of these. We got to make sure that this has some good IDs in there. And then we don't care about the return value here. And actually that's in the wrong spot. It should be here. Then when that is finished, we want to insert our actors. So we're going to do basically the same thing here, except all of our actors just have a name. So, Amir, can you tell me an actor who is in the movie C? Let's do 2. We'll do 2 for each of these. What am I doing? Okay. So then we'll do 2 for Jaws. Roy Schneider and Richard Dreyfuss. Yes, I was trying to not embarrass myself by forgetting the names of them. I'm not sure I would have spelled Dreyfuss correctly for shot, or Schneider for that matter, or Scheider.
Okay, for C, it's gonna be Christian Camargo and Nesta Cooper.
All right. What was the first one? Christian.
Oh, Christian. Camargo. Camargo with a C.
Yep, I spelled it correctly.
Okay.
And who's the other one?
Nesta Cooper.
Mm-hmm. Got it. All right. And then It's a Wonderful Life.
Oh, James Stewart, man.
James Stewart. I know my good friend Jimmy. I think at this point you've all heard the voice that I do for my dad, which it's literally Jimmy Stewart in It's a Wonderful Life. Hot dog. Wish I had $1 million. I just don't know the names of literally any other actor in that film. Even though I've seen it, man, probably like 50 times. It's a good movie. All right, Donna Reed plays Mary. Okay. So now that we need to write our intermediary table, and this is the annoying part about seeding databases with many-to-manys in here, is just writing this. It is boring. Oh, I'm going to need to know the names of the characters they played in here too. Okay, so when that is done, we're going to add to our cast table the relationships between our actors in our movies. So for this, I'm not going to specify the ID because I don't care. But we need the movie ID and we need the actor ID. and then we need the character name. So I'm going to write the 2 for each movie. So this is going to be 1, 2, 3, 4, 5, and 6, and we're going to do 2, 2, 3, 3. So 5 is going to be good old George Bailey. Hee-haw. These jokes are killing it if you're familiar with that film. And then Mary Hatch. I didn't know Mary's last name until today. The things that we know. All right, and for Jaws, they don't have last names. That's cool. So that's going to be Brody and Hooper. And then for C, thank you for not letting me just type whatever I felt like in here, Amir. There we go. Is this correct? Yep. All right. Incredible. All right. So this should be good. Let's see if I made any typos in here. npx next seed : run. And let's see what error I get probably. Oh, it worked. Whew. Most of the time it's not going to work. First shot. Okay. And so that's our seeds for many to many. We are going to describe each of the tables that contains the information for that film, for that actor, and then we need to describe the relationships between there. So each film has a number of actors in it, and this relationship requires an extra piece of data, which is the character name. And at the start, we got to make sure we truncate in the correct order. Got to truncate in the correct order. And Louise mentioned today that Postgres doesn't really like truncate. There's ways of getting it to work, but I'll cover that when I do kind of a thing about Postgres sometime next week.
So for the seeding, you're doing it all in one file. It's not an issue. I mean, you just chain.dens and then apply it to the table.
Yep, because the way I'm saying this is a presumption because I haven't read the next source code, but the way I assume it handles the multiple seed files is it runs these each, wait until the promise that this returns resolves, and then runs the next seed and a .then off there, right? That's why it's important that we return this promise, so it knows when whatever we're doing in this file finishes. So I could have just done this part within this file and then done the next part in the other file, but if I want to, I can just do it all in here and make sure that the previous database operation finishes before I try to do the next one. So, yeah, that works just fine. And the same way we can chain the .thens within our chain the .create tables within the schema files within our migrations. So there we go. And I'm going to, did I leave the terminal open? I did. And so now we can just check and make sure that data was in here. I'm going to set mode to column. And I'm going to select star from movies. Hey, we got some movies in there. I also want to set headers on. There we got some movies. And so one of the things that I like to do when writing queries that I may not entirely understand is I don't always write them within the next query builder format first, because it can be hard to get feedback about that, right? Because in order to run those, you can run them in various means, but we generally then need to set up our routes and make sure that's good, and then run the queries and then debug the errors. I can write this right here. So I can select star from movies, and I'm going to join with the cast on movies.id equaling the cast.movieid. And it didn't like that for some reason. Join cast on movies ID. Where was my syntax error? Select star from movies. Join cast on cast.movieid, where that is equal to the movies.id. Anyone see what I'm doing wrong? It's probably something very silly. Okay. Join onto our cast. This has got to be title. All right, and it did a bunch of joins. And then on, let's just do ID is equal to movie ID.
Would that be an example of a cross join you just did?
Yes, what I did there without specifying an on, that performs a cross join. We end up with n times m rows. So we have n rows inside of our movies table, and then we're joining them to every row. Each row in the first table gets joined to every row in the second table. So we end up with, in this case, that's going to be however many that is. I forget how long these are. Okay, that worked. Why doesn't it like the second dot here? I mean, it works because the column's not ambiguous, but I don't know. So we could do title and then actor ID, and now we can see that we're getting the actors here. So this can help us plan out our queries when we use next, which is what I'm going to do to write the rest of our queries. So let's go ahead and do that. So in order to do this, I have my database all set up and it's all seeded, and that's great. And I don't have anything that even suggests that this is going to be an API yet. So I'm going to create an index.js. We're going to do our default things by requiring express. And then I'm going to make our server. And then I'm going to do server.use, express.json. And I'm going to say port is equal to 6002. That feels good to me. Then we're going to do server.listen on port, and we're going to console log server on our port. All right, and if we want to be fancy, we can add our or in here for process.env.port. So there's our server. Now I should be able to run it, but I haven't set up the script inside of my package.json yet. So I'm going to have to add a field in here called scripts, and then add a script called server, and that is going to run nodemon on the index.js. And we're going to run yarn server. Hey, it crashed. Why didn't it like this? I misspelled express. And none of you told me. Wow, you just watched me do that. It was very cruel of you. All right, there we go. So now our server's up and running. So then let's go ahead and start defining our models. So we're going to start out with movies first. That's what I feel like doing. So we're going to create in here a movie model file. And we're going to require our database connection that we already set up, which is going to be up a level, down into data, and in our db.js. And then I'm going to do module.exports. You can put this at the end. I've been putting it at the top to try to force me to remember, but I'm going to have it at the bottom. And we're going to define our get, which fundamentally, right, we could just get the movies table. And that's what I'm going to do. I'm going to try to get this thing running, get it humming along before we actually try to do anything too fancy. So let's create another one of these, WebDb 4. And I'm also going to write get by ID, which I'm going to cheat and just have it do get and then chain a first on there, because we're allowed to keep building our queries up until we do a .then, which is when we wait for that response to come back from the database. And I think that's all we need for now. We'll get the gets rocking and rolling. So
Henry, if you do that though, like, what if you have multiple items in your database? It's not going to necessarily get the correct one, right?
Oh, yep, that's because I forgot to use our where. Thank you, Amir. Yeah. So now this will work. I can chain the where and then the first. I was just getting very aggressive with this, but you would need to specify which movie you want to get by ID. So then I'm going to make my movie router. I'm going to make our router, and I'm going to do it with this one line here because I am very cool. Export the router, and now we're going to start defining our routes. So for this, we're going to make our request. I'm going to realize that I haven't imported my model yet, because there's lots of things I forget to do. And that's going to be our movie model. It's very hard to talk and type at the same time. So we're going to call movies.get, and then when that finishes, we're going to get our movies, and I'm going to be lazy about my error handling, and I'm just going to handle the success case here. And we're going to give it the movies back, and we also need to add res and rec in the correct order. Ooh, man, it's been a long day. All right, so there's our basic movies route. Let's test this in Insomnia and see if everything is working top to bottom. So we're going to get movies. We're going to be on localhost 6002. And we got to send our request to movies. And I have not actually hooked this up to the server yet. So these are all the things that we need to remember to do. So I'm going to require our movies router. And that's going to be inside of our movies directory at the movies router. And then I need to server.use our on the route movies, our movies router. Oh, and we crashed probably because I misspelled something. Let's see what this is. Require is not defined. Wait, but that's spelled right, right? Oh, it's because I spelled it wrong in the DB file so long ago, but I never actually ran it. And we never encountered this error. There we go. So now our server should be humming along. And yay, we can get our movies. We can get our movies. Now I want to be able to get an individual movie. So we're going to do that. We're going to go into our movies router, and we're going to write the get for the specific movie. So we're going to do that at /:id, rec and res, right? All of our default stuff. We're going to call movies.getById, and we're going to give it the ID that I prefer to destructure out of our rec params from our URL. And then I'm going to get by that ID. I am going to get the movie. I will do 404 error handling here. I will check and see if the movie exists. In the case that it does, we send back a 200 with the movie as our JSON payload. Otherwise, we get a 404. And I'm too lazy to write an error message. There we go. So let's try and duplicate this. All right, and we get our individual movie. We get our movie. But now what we want to do is I want to be able to get the actors that are in this film. So I'm going to do that. We can also, like I did in the recitation today, add the actors as an array to this movie object. But let's just go ahead and try to do it separately first. All right, let's do that. So this is where it comes into play, where we want to organize our models and stuff. Because I could write a function in here that's, get actors by movie ID. Or I could write that inside of the actors model. I did it inside of the other model earlier today, so I'm going to do it the opposite way here. So I'm going to write function get actors by movie ID, which doesn't have to be this verbose but that's how I decided to do it. So then I am going to get my, it doesn't matter which one we start with, but let's get the cast table. Let's get that. And then what I want to do is I want to select some items out of this. You know what? Let's read our where first. Let's get the boring version working better first. So I want to do the where the movie ID is equal to the movie ID that got passed in. I'm not going to do a first because I want all of them. So now let's replicate this route. And let's export this. Aha! Aha! You all tried to trick me. But I won't let you. See, I learned to. So we're going to do /movies on here. And then we're going to do get actors by movie ID. And then we should get our list of actors. And I'm not going to do any error checking here, because some movies may have no actors, because some movies are very low budget. Alright, and let's check and see if this works. So I'm going to duplicate this, and we are going to get movie actors. So let's try to get the actors for C. Hey! And we get a 404. Oh, it's because I wrote this endpoint wrong. We don't want to get the movies for the movie. We want to get the actors for the movie. And there we go. I spelled something wrong. Get actors by movie ID. Get actors by movie ID. Get actors by movie ID. What doesn't it like about this? It doesn't like that I haven't saved that file yet. Oh boy. Oh boy, we're just seeing all the mistakes here. So this works. This works. We are able to get the actors that are in this movie, right? Movie ID 1 in both cases. But this isn't a satisfying thing to receive. This isn't good. I want to know the actors. I don't want to have to make another query to find out who the actor ID 2 is, even though I know it's Bob Hope, who very famously starred in C. So this is where we can add our join. And we can do this after we get this working, right? My mantra from React was get things on the screen as fast as possible. My mantra here is get things in Insomnia as fast as possible. I want to see things working before I try to make it more complicated. So now we're going to perform our join, and we're going to do that onto the actors table. And we should be fine doing an inner join here, because the foreign keys should exist in both places. And I want to do this on where the cast.id is equal to the actors.id, except this is going to be the actor ID. Now it can be annoying to type out cast and actors here, and I saw a lot of you today when you were doing your SQL queries, you were renaming the tables in order to make that shorter, and we're absolutely allowed to do this here. I can have cast as C, and I can have actors as A. So now this is C.actorID and A.id. And that's just going to make it a little bit simpler on me. And so this will work, but we run into this case, right, when we join. When we join, things can get messy, and we have an ID in both of them. And I'm not entirely sure which ID ended up getting picked. So when we join, we generally want a select. Now, in Next, you don't have to keep the order of these methods consistent with the way they're going to be written in raw SQL. I prefer to, but you can write them in the order that makes sense to you, but I like to keep them in SQL order, as it were. So I want to select, let's just get the character, or the cast dot character. Let's get the actor.name, and let's get the actor.id as actor ID. You know what, we can just get this out of our cast table, so we don't have to rename it. And we don't need the movie ID here. And we could have the relationship ID here. It depends on, you know, who exactly is consuming this data and how. It would be useful if they wanted to delete things. So I'm going to call this the c.id as cast ID. So now we're going to make this request, and we get nice data here. We get our character name, we get our actor name, we get the ID of the actor, and we get the cast ID. So this is good. This is good. Right? Any questions here?
Yeah. So Henry, regarding writing the raw SQL, is there any issues if we just did everything just using the connects.raw? Just wrote raw SQL?
Yeah, so you could. I would recommend using the ergonomic next where possible. Otherwise, things can get weird, right, when we have lots of user input. Right, when we're doing this where, I could do this with raw SQL, and it would let me do something like next.raw, and I could say where movie ID is equal to, and what we wouldn't want to do, what is very, very dangerous, would be to do something like this. Because this does not protect us against SQL injection attacks. So someone could write a special string here, right? And I can even put quotes around this string. But if someone made the ID something that looked like this, you know, 0, end quote, semicolon, drop, table, movies, and then semicolon, dash, dash. Dash, dash is a comment in raw SQL. They would be able to execute any SQL command that they want to in here, including deleting all of our stuff. And that's bad. And that's bad. Next automatically handles escaping the strings that we give it, so we don't have to worry about that. In raw queries, we can take advantage of this by, instead of using string expansion, we can put a question mark here, and then I can supply arguments in order of the question marks to have them put in there, but it can make it a lot more difficult to read. And we also lose some of our ability to write really dynamic queries. But there are database features that are absolutely not supported by Next, and so you will have to write raw Next sometimes, and sometimes it's honestly a little bit easier. But when you can, I would recommend trying to stick to what Next has been nice enough to provide us, unless it's like really, really awful. So something I could also do, if I want the get by ID to include the movies as a subarray, we can use our promise.all. So I can make a variable and call it something like movie query, and I can give it the value of our query. Oh, that did not copy what I wanted to. And then I can also get an actors query and call get actors by movie ID and give it our ID here. And I can do the .then chaining. And if this is the first time you're seeing this, I'll recommend you to the video I made earlier today where I explain how this works. But promise.all lets us give an array full of promises, and it will combine them into a single promise. And then we can chain a .then off here that will only run when all of the promises have resolved. So I can give it my movie query, and I can give it my actors query. And then, when both of those is finished, I'll receive an argument that has the values for each of the promises inside of an array in the same position. So this is going to be my movie, and this is going to be my actors. And I'm going to add to a key inside of movie called actors, the actors array, and then I will return my movie. So now, when I go and get my movie, we get a 500 server error because I did a goof 'em up. Cannot read property then of undefined. And that is because I didn't return my promise. So now when we get our movie, we also get this subarray full of actors. And we can test this out on our other films. And it will work really well. And everything is good in the world. So any questions with this?
Can I ask a question about the like many to one, many to many kind of thing for structuring a schema?
Yeah.
So my understanding is that if you're dealing with a many to many relationship, you need an intermediary table. Like, but if it's many to one, then you may not need that.
Yeah.
Like, you could just have one table of, I don't know, movies, and one table of I don't know, what is something that could only belong to one movie?
What about reviews?
Yeah.
Yes.
Reviews. And then you would just give the reviews a movie ID. You wouldn't have to make a movie reviews table.
Nope.
Right?
Nope. If it's a one-to-one relationship, right? The idea between a one-to-one, or I'm sorry, a one-to-many relationship is that we have a parent table that contains the information only relevant to it. And then we have another table that's dependent on that table via a foreign key, right? So reviews are of a specific movie. So the review needs to know what movie it is referencing. And so we just put the movie ID in there. And we can easily perform wheres in order to get all the reviews for a specific movie. All a many-to-many is just two one-to-many relationships, right? If I hide the actors here, the idea is that there are many cast members in a movie. So this is a one-to-many relationship, right? Movies only has its information, and the cast has a movie ID in there. But because we don't want to duplicate our actors' information everywhere, we also have a one-to-many relationship on the other side, where each actor can be in multiple casts, right? They can be in multiple productions. And so the actors only has the information necessary to it, and the cast contains the actor ID. So it's just two one-to-many relationships. And the intermediary table holds both of them, going in both directions. Whereas our reviews table only goes in this one direction. Right? It just has the ID of the movie it references. Cast has the movie ID, but it also has the actor ID.
Thank you. Sorry. It was taking me a little to wrap my head around.
No, I mean it should, right? Like this is not easy, obvious stuff. This is hard. And in some ways, until today I didn't understand certain finer aspects of it until I revisited it with all of you. So yeah, what I know I've gone over, and I'm stealing time from the after hours people, but I would like to do one more thing. We could either add a one-to-many relationship with the reviews here, or we could restructure our schema to make it more general and be able to support things like, oh well, what if we wanted to add directors? Well, then I would need to add a table called directors, right? And then I would need to set up another relationship here. What if I wanted to add gaffers and cinematographers and all these people? I wouldn't want to keep adding tables. So how could I restructure this in order to avoid that? Out of those two, which would you prefer to see? Keeping in mind that the second option is going to be longer.
And what are the two options?
Adding a one-to-many relationship with reviews, or adding or restructuring our schema to support arbitrary people working on a film.
I would say the first one makes more sense to me.
Okay. Cool. Well, then let's do that. I might do the other one anyway. Depends how I'm feeling. So, right, here's the schema that we're going for. We have movies, and this doesn't have to be affected at all. This is one of the really nice things about additive migrations, right? Movies doesn't care about this relationship. So we can just add another table called reviews, and we can have it reference the movies. And so this is a great use case for having another migration file if for some reason we needed it, right? We have deployed to production and now we want to add reviews. I could very easily modify my existing what did I call this bootstrap? modify my existing migration, but I'm going to add this as another migration just to show that we can without it being a huge pain when we have these additive migrations. So I'm going to open up my terminal. I'm going to kill the server for a minute, and then I'm going to run npx next migrate make reviews. And that's going to make another migration file for us called reviews, and I'm going to write my migrations here. So we are going to return next.schema.createTable, and then in here we're going to make a table called reviews. It's going to get our table as an argument, and I'm going to write the down schema real fast, which is going to be a next.schema.drop table if exists for reviews, and there we are. So then for the schema of this table, all we have is we're going to need an ID here, right? And we're also going to need a rating. So that's going to be table dot, let's make it a float so we can have fractional ratings if we wanted to. And we're going to call this rating. And this is required, so it's going to be not nullable. We'll also add an optional text that is going to be, let's just call it review, right? We could also call it comment, something like that. And then we're also going to need our foreign key. So that's going to be table.integer, and we're going to call this movie ID. And it is going to be unsigned. And it is going to be not nullable. And it is references our movies ID, which is just ID in that table, and it is in the table of movies. And that's our schema for this. Right? We have the information, or yes, what's up?
Yeah, is it required to do the unsigned for the IDs, foreign keys, and primary keys?
Yes. Technically, it's not required. You could have a signed primary key. It would just start at 0 and end at a slightly, well, half of the number it could go up to. But when we use increments, it makes that primary key unsigned. And when we use a foreign key, it needs to be the exact same data type as the primary key we're referencing. So if they're both unsigned, we can do that. If they're both strings, we can do that. But we can't have one be a string and one be an integer, or one be a signed integer and one be an unsigned integer. Now, I'm not entirely sure SQLite would yell at us for that, but it's very possible that it would cause very, very strange bugs, because signed and unsigned integers are both binary numbers. It's just that signed integers reserve one of the binary numbers to indicate whether they're positive or negative. So maybe SQLite wouldn't yell at us, but I don't want to, run into weird bugs where we start overflowing one thing and it is being treated as a negative number when it's actually just a large positive one or something like that. So yeah, got to keep these data types consistent. And now I already have my migration it bootstrapped, so I can use npx next migrate up. Up will run the next migration. Latest will run all migrations that have not been applied. Here they mean the same thing. So I'm going to do this, and there we go. So we can check inside of our SQLite, and we can see that we now have the reviews table, and I can check the schema on that. And there we go. We have all of our information within here. So do we have any questions about this schema, right? This one-to-one. Okay, cool. So now let's increase our seed data. And I don't necessarily have to add another seed, because when we run seeds, it's going to truncate anything anyway. So I can add it in here just fine. I just also want to make sure that before I truncate movies, I want to truncate the reviews. I have to get rid of the dependent keys before I get rid of the movies. And I also have to insert the reviews after the movies. So let's do that down here. Then I want to return next on movies. And we're going to do an insert here. I want to point something out because I think this is a lot of things, you know, people can go without realizing for a long time. This next that we have here, it's the same as DB. They're the same thing. We just decide to call our database connection DB. We could call it next if we want, right? How we do db.movies.insert. Same thing. Same thing. And in fact,
where do you define that though?
it's an argument to this function, so I could just rename it
okay.
DB. They call it next by default, but we can do all the same things we can in either place with this. Okay, so we have our next, and we're inserting. I don't need to define IDs here, but I'm going to need a movie ID. Let's review It's a Wonderful Life. We're going to give it a rating of 5, and let's add our review as hot dog. Gosh. Okay. And let's give it another rating, and this one is going to be hee-haw. And then let's give C a rating and say I didn't see it. Oh gosh, I'm such a funny man. How do you all stand this? It's absolute hilarity while you're trying to learn. Okay, so then I can rerun my seeds. It'll delete everything I already have, but I didn't add anything, so that's fine. So we're just going to do this with npx next seed : run. Ah, awesome, we got an error. Cool. Cool. Usually our seeds don't run the first time. No column named movie ID. I thought I did have a column named movie ID. Did I goof that up? Sure looks like I have a column named movie ID. Oh, it's because I'm inserting into movies, not reviews. Oh, man. Hey, there we go. And we can check this, and I can select star from reviews. And there we go. There's all of our reviews. And we can write our model for this really fast. I'm going to just keep writing it in our existing movie model. So I'm going to call this function get reviews by movie ID. We could pick a different, shorter naming schema. This could be something like, you know, get movie reviews, or even just get reviews, right? Because this is going to be on our movies model, so we may implicitly know that this is doing it for our specific movie. But I'm going to stick with what we have. So I'm going to do this on DB reviews, and then we'll just get this working. And honestly, that's probably fine. The only thing that I'd really want to do is I don't even need a join here because we're doing it. Oh, well, we would need a where. I don't even really need to do a join here because I want to get the reviews specifically related to this movie. So I don't really even want any reference to the movie. So we would just add a select here, and I would want to get, let's get the ID here, let's get the rating, and let's get the comment. And that should be good. So then I'll go into my movies router, and we'll add another endpoint here. This time we're getting the reviews from a movie. We're going to do the same thing. We're just going to change this word actor to be reviews. And we're going to change that here as well. So I'm just going to change actors to be reviews. All right, and let's test and see if that works. And I killed my server and didn't start it back up. So let's run our server again. And let's spell reviews correctly. And we get a 500 internal server error. And that's because I did the bad thing. I did the bad thing that I do. But you're going to do this too. So I like to comfort myself by saying that I'm teaching you how to debug these errors. And it still doesn't like that. Did I spell this wrong? I did spell it wrong. And our request is not finishing because of some reason. SQLite error, no such column comment. That's because I called this column review. All right, there we go. There's our reviews, and I don't need to do any joining here because I'm not interested in that information. If I were to write a reviews endpoint, if I wanted to get all the reviews, then it's probably a good idea for me to get a join and get the name of the movie that we're reviewing here. But don't need it for this specific situation. So, do we have any questions about our movie reviews? No? Okay. Well then, I'm going to do the second part here, which is designing the schema. I'm not actually going to implement it, but I want to talk about how we would improve this. So, if I wanted to add directors, right, this would need to be another table in the way we currently have this set up. But what about the fact that actors often direct, right? We're duplicating our data. Our data isn't only unwieldy in that we have to make new tables for each new role that we want these people to play, but we're potentially duplicating people. And that's going to make it difficult to find all of the credits for a singular person if we want to find both the films that they acted in and also the films that they directed or worked as a cinematographer on or whatever. So instead, what we're going to do is we're going to generalize cast here, and I'm going to rename it. I actually want it to be called credits, and I should scale up my eraser here, make it a little bit easier on myself. We're going to generalize this table, and we're going to call this credits. And we're no longer going to have an actor ID. We're going to have a people table, right? Because the actor is fundamentally a person. A role is something else that they do that we can store in another table. So we would also necessitate removing this character, right? Because suddenly not everyone in our credits is an actor. And so what we would do here is we would have another table called roles. And this would have a role, and this would be something like actor, director, gaffer, best boy. And we would need another many-to-many relationship here, where each credit, right, or wait, no, this would be a one-to-one, because each credit would have a single role. So we would need here a role ID. And this would connect into our roles table.
Quick question about the one-on-one relationships.
Mm-hmm.
So if we're doing a one-on-one relationship, where do we put the foreign key, or is it just arbitrary which table we put it to?
The foreign key always goes on the many side, right? Because a movie can have multiple reviews. So a movie cannot contain a value called review ID because it can only have one, right? We only have one
I'm
row.
I'm talking about one-to-one.
Oh, for one-to-one?
Yeah.
We generally don't write one-to-ones is the answer for that. You could have it in either, but if you have a one-to-one, you would generally just want to put it in the same table. There are going to be cases where that's not true. But yeah, you could do it arbitrarily. And I may have misspoke and called this a one-to-one. This is a one-to-many, right? Lots of credits can have the same role. Lots of this can have the same role. But now we've lost our character name, right? We've gained the ability to have all these other things, but actors still have a special a special character name associated with them. So what we could do is we could make another table, and we could call this characters, right? And this would contain the character name. And now we need to figure out a way to perform a relationship here. And this is a use case for a one-to-one, in that each character name is going to be uniquely tied into a single credit, right? But the reason we're not doing something like having a thing called character in here and just making this nullable is that we're wasting space. For every one of these rows, we have to store enough space in order to hold that string. And the vast majority of people working on a film are not actors. They don't have character names. So it's really putting out a lot of data in order to support what is essentially a special case. So instead of doing this here, we would have this name in here, and then this would have a reference to a credit ID or whatever we have the primary key on that table being. And then we can do a left join. This is a case where we would not want to do an inner join, because not every credit is going to have a character associated with it. It's only going to be for actors. So here we do a left join if we were trying to get the entire cast and crew of a film. Because we want to join onto the characters table, but we don't want to only get things that have, both sides of the join, right? We don't want to get only the inner join where things match up. We want to get all of the credits people, and the ones that have characters, we want to get that row in there too. So this would be the more general schema here, where we, instead of encoding information about a person's role in the film into the table name, right? Instead of having an actors table, we'd have a people table, and then store the role in another table, and then also recover the ability to use characters via another table. And this would be a good case for getting things working simpler, right? We could put this character name in here and make it nullable and see if that works, and then split it out into this other table. And then split it out here. So I immediately contradicted myself about one-to-one relationships. This is a case where we'd want one where we have a nullable value that is going to be very, very frequently nullable. So we put it in another table to avoid wasting space. Any questions with this design here?
Wait, sorry. Why would you want it to be nullable, the characters and credits?
Because the credits now includes every person that worked on a film, and I need to change this from being actor ID to person ID. Oop.
Oh, I see. And so, like, the cameraman doesn't have a role.
Yes, yeah. So it would need to be nullable in order to support all that, but I don't want to waste the space, so I can drop it in another table. But we could also make it nullable. Both would work. One would require more joins, right? That's going to be slightly more computationally expensive in order to process the joins. The other is going to use more space, and that's a trade-off we would have to make. But generally, joins are pretty quick, and we could also avoid most of them because we wouldn't necessarily run a query to get the entire cast, crew, and character names. We could just get the entire list of people that worked on the film and the roles that they had, right? And then in the special case where we want the actors, we can do that join and get that there. So we don't have to always make that join. So I would prefer this schema. All right, cool. Any other questions or things that we want to talk about here?
Yeah, I apologize if it's background noise, but
That's all right.
yeah. So I had a question regarding So if you have a many-to-many relationship, and
Mhm.
then you have a on that many-to-many third table that you're managing the many-to-many relationship on, you need to include the cascading because or is cascading only applicable to join tables where one is a child of the
Uh,
another table?
so this is a great question. We need to consider the cascading behavior every time we have a foreign key. I did not. Um, I did not. And what that ends up meaning implicitly is that on Cascade these restrict. If we try to delete the movie and there are actors that are still in the cast of that movie, we're going to not allow that to happen, right? We're going to throw an error. So cascading is always in play. It's just that in some cases we don't want to set it manually. So what I would want to do is if I delete a movie from my database, well, then I probably do want to delete all of the references to it in the cast here. So I would want this to have on delete, not one delete, cascade. And probably the same thing for on update. If I were to delete an actor from my database, well, they still had a character in that film. Right? So I don't necessarily want to remove the character. It's just for some reason maybe I've banned the actor from my platform or something like that. So we could set different values here. For on delete, we could have set null. So what we would end up doing is we would end up setting the value here to be null. And this would necessitate some changes. One, we would have to remove the not nullable here. Two, we would have to change this unique to now contain the character as well, because we could have potentially multiple nulled actors for our film. And then on update, we would probably want cascade. We'd want to keep it in line with it, whatever we changed the parent value to. So anytime we have a foreign key, we have to consider what happens when we delete or we update the row that it references. Sometimes we want to cascade, sometimes we want to restrict, sometimes we want to set null, sometimes we want to set default. And I think those are all the options we have. So, yeah. Good question.
I had a question. Could you by chance go over a little bit the notion about primary keys? I'm not totally sure. Like, I understand tables have primary keys and they're usually the ID, but sometimes you have to explicitly set it.
So the way the primary key works within the table is we need some way to uniquely identify every row in our database, right? Let's say I had my actors table, and we have names, and they're not unique, right? Actually, technically, because of the union rules, every actor's name is unique. But let's assume that they're not unique. We could have two actors with the same name, right? So how would we identify those rows as being different? Well, we added them at different points in time, right? They're two different entities. And so what we do is we add a field that we call the primary key. And this is both something that is guaranteed to be unique for that row, but also set up in the way that the database works so that both searching for it and joining against it is very, very quick. That's the way the data structure is set up, is so that things are indexed by their primary key so we can find it via the primary key very, very quickly. Normally, if we were writing this in raw SQL, I would have to specify the column name of this and the data type it had. So I would call this integer.id, and I would say that it's unsigned because I want to start at 0 and I don't want to have negative IDs. And then I would make it not nullable because primary keys need to be always set. And then I would make it the primary key. And I would also want to set it to auto increment, which I don't know what the syntax for is here. Oh, it's dot increments. So I would need to set dot increments. Or no, that's dot increments. How do I set? I guess primary key probably does that automatically. Let's look at the syntax for primary. All right. Dot primary. That's table dot primary. You need to create. No, whatever. Well, you would generally set that to be auto incrementing. It might do that automatically with this dot primary here. I'm not sure. But we would set up some key to be unique and generated for every entity that is inserted into our table. We can have it generated automatically with our auto incrementing key, or we could just have some property we're inserting into the table be guaranteed to be unique, like the VIN number for each car, or the ISBN for each book. What increments does is it does this for us. And if we give no argument here, it decides to name this column ID because that's a good default name. We could choose to call this, for example, actor ID to make it consistent across our foreign key references. We could call it anything we want. It's a banana name. But if we leave it out, it's automatically set to be ID for us. So we always need a primary key. We often set it to be this auto-incrementing integer. We can make primary keys that are composed of more than one row. We can have a composite primary key, like I showed a bit earlier. We can have these two values be the primary key because those are the values we're often going to search against, right? That's what we want to index. And we can also save a little bit of space for not storing another ID here. So that's what primary keys are for. Does that answer your question, or did I kind of misinterpret what you had wanted to know?
That covers it. Thank
Okay.
you.
All right, awesome. And then Amir asked, on the table that is used to manage many-to-many relationships, I don't think we need to include the on-delete cascade because the foreign keys managed by the manager table doesn't have any real children data. Or is it the case where if you include it, then if you need to delete the manager table, then it would delete the other tables? So cascade kind of goes the other way than I think we often interpret it to be. So it is not what happens when I delete this row out of cast. It's what happens when I delete the movie whose primary key we referenced, right? We do on delete on update on the child. We do it on the foreign key. So I'm saying if this cast member is in a movie with the ID of 3 and we delete that movie and that primary key no longer exists, how do I want to rectify the situation with this row? Because we cannot, under any circumstance, unless we forget to set our pragma and SQLite, reference a primary key that does not exist, right, as our foreign key. We cannot do that. So I have to choose how to resolve that. And I do that by setting the behavior I want on delete. The easiest way to handle it is to say cascade, which means when we delete the primary key that this row references, also delete this row, right? If we deleted the movie, then I don't want to keep track of the actors that are in that movie anymore. Gone. We can put restrict in here, which will say, you know what, you're not allowed to delete the movie until you clear out every actor that's in this, right? You're not allowed to delete that. It will stop that delete in its tracks. We can also set null, which means we can't reference a primary key that doesn't exist, but we can just set our this field to be null, right? This doesn't have to be not nullable. Our primary keys need to be not nullable, but we can have optional foreign keys. And there's also set default, which will use the default value for this column instead of null. So on delete and cascade talks about what happens to the child data when the parent is deleted. And the parent has the primary key, right? That's what we're deleting. The child references that via the foreign key. So,
but on the manager table, are
yes.
those foreign keys, are those considered children?
So a foreign key is always referencing some primary key, so we often refer to it as the child, right? The primary key is the canonical placement of that key within our database, whereas a foreign key is merely a reference to that, right? So we often refer to the row that has the foreign key reference in it as the child data, right? Our movie has multiple reviews. The review is the child of the movie, right? That's how we encode that in the object relationship that we produce with our queries, right? So we're describing what happens when we delete the movie. What do we do with the reviews? What do we do with the cast members? So, excuse me. That's what we're talking about here. Does that make sense?
Yeah, I think so. So anytime you have a foreign key, the potential data that the foreign key has could be a child.
No. The foreign key is always intrinsically tied to the primary key that it references. And we can delete a row that contains a foreign key at any point in time, right? We can delete a review, and that doesn't matter in terms of the way that our database works, right? We can delete a review. Doesn't matter. What happens if we delete the movies that our reviews reference? Well, we have to resolve that somehow, because we can't have a foreign key that points to a value that doesn't exist anymore. So we have to choose whether to delete, whether to stop that delete operation, or to change the value of that foreign key. This is true even in one-to-one relationships, where if we delete the primary key, we can't have a foreign key hanging out in another row that points to a primary key that doesn't exist. So we have to choose how to handle that. So foreign keys are dependent on a primary key. And if we delete the primary key, we have to resolve the fact that the foreign key no longer has that dependency.
I see.
Okay.
I think that makes more sense.
All right. Awesome. Yeah, it's one of those things where like it's definitely one of the weirder concepts that we talk about here, because I also I feel like it goes the other way, you know. Like we talk about what happens when we delete the parent on the parent, but no, we talk about what happens when we delete the parent on the child. What happens when we delete the primary key on the foreign key that references it. So, yeah, all right. Any other questions here? Okay, great. Well, I think I'm going to wrap this up. I think this is the longest recitation that I've done so far, so I apologize to all of you that stayed through this and to everyone watching later for having to make it all the way through this. So I will see you all later, and good luck on your sprint challenge tomorrow.